Today we're going to look at a very cool piece of code which actually gets GPT 3.5 Turbo or GPT-4 to play blackjack in an OpenAI Gym reinforcement learning environment, which recently have changed the Gymnasium. But anyway, let's run this and see what happens. Users ask how many iterations to be played. This is how many number of games. Let's just say 5. And then the game 1 starts. And let's take a look. We get some observations. This is player's cards. This is the dealer's cards. We're going to get reward in the end. Termination is when the game ends. I'm not sure what truncation is, but our return is like the cumulative if you're winning or losing in the total. This is dealer's cards so far. This is player's cards. Player's hand value, dealer's hand value, and the GPT 3.5 chooses the hit is to receive another card. And here it receives a 6, which makes it a total of 20 from 14. So now the player hand value is 20 against dealer's 13. GPT decides to stay, and then dealer draws a card, 9, and actually makes 22. And we get player wins, dealer busts. And then we have selected to play 5 games. But before we move on, we do have a return of 1. So our reward is 1, our return is 1. We can continue on to the next game. The game 2 starts. This time the player has 15 versus 3 of the dealer. Decides to stay. Dealer draws a card and actually busts, so player wins. Now our total return is 2 because we got another reward. Let's play another game. Game 3. The player have 14 versus 5. And then player decides to hit. And then gets another card. So he decides to hit twice. And in the end, player busts because it reaches the 24. Because in blackjack, if you have more than 21, then you bust. We can continue playing, but this is how it works. It's really cool. So I have found this example implementation is simulated environments with Gymnasium. So what we're using is for what is formerly known as OpenAI Gym for reinforcement learning. Those of you who know, but it's recently turned into Gymnasium. You can actually go and take a look at their GitHub. I'll put the link in the description for both. In this Langchain, we are using Langchain as well, and we are using chat completions. In this implementation, however, I had to modify this deeply because we really don't get any decent information here. We don't even know what these are, and we don't know what the actions are. Also, this actually only plays it for one time. So I modified it so that we actually get some decent information. We keep track of the ongoing rewards, and also we can play as many times as we like. I'm going to make this code that I modified available to my Patreon supporters. The link will be in the description. I also want to mention that I've created the EcoHive AI Academy at ecohive.live. You can search all the 120 plus videos that I have created, free, no sign up required. Just come here and search for what you need. It also comes with links to the code downloads. Link will be in the description for the website. It's ecohive.live. Let's take a look at the code and see how we can build something like this. So before I start, I guess I'll talk about the requirements. So we are using Gymnasium, which was formerly known as OpenAI Gym. We are using Langchain, OpenAI, and term color of these versions. This will be available at the Patreon as well. So we are importing Gym importing Gymnasium as Gym. We are using Tenacity. Term color, we are importing from term color, just as for colorful terminal outputs, as you see here. Works nicely. We are importing from Langchain.chat models, chat OpenAI, and the schema of the human and the system message. We are importing the regex parser from Langchain. This is all actually automatically implemented in the Gymnasium agent class. For example, here we are getting the environment, which is an OpenAI Gym environment. We are defining it here. Okay, and the model as well, which we're going to see down below. These are the instructions, I believe, but this is what equates to the system message. So it says your goal is to maximize your return. Some of your rewards you receive, I'll give you an observation, reward, termination, flag, truncation. So these will be the inputs that the model receives, and you will respond with an action formatted as action equals the what have you. And action number, there are two actions. Action number 1 is to hit to receive a card, or to stay, which is action 0, I believe. And then so this is just additional information on how to receive the action. And this is how we are receiving the action, plus the message history. This is for reset. Those of you who know reinforcement learning, we do have to reset the ongoing game every so often. So from this point on, I have some methods that I have defined. Get player cards. So we get the player cards so we can actually print them, such as like right here, whatever the player cards are. Same for get dealer cards so we can display them. These weren't available in the original implementation. Print colored to be able to do this colorful displays in the terminal. Get hand total. This is to receive the hand total so we can actually print these like total hand values. Print cards in total. I believe this is all. This is also to get cards and to get hand total and to print it right here. I might not have used all the methods. I'm not sure. We might have some redundancy, but anyway, print action description. So at some point we are going to end the game and we're going to say what happens if it's a draw or stay. Action description. Oh, here the action description is a draw. Yeah, but I've changed it to hidden down below somewhere. But you can draw a card or stay, right? I guess draw makes more sense. If we get there, maybe I'll modify it. And then we look at the reward. If it's over 0, then we won. Otherwise, we lost or we drew with the dealer. Then we print that. And then we print the hand values, player total, dealer total, right here. And then we are printing the winner, such and so. We're getting the player total, dealer total. And if the player total is over 21, player buzz. So these are all our conditions. We are checking for a tie and say nobody wins in that case. Otherwise, the winner is the winner, either the player or the dealer. Then I will also introduce the play iterations method so that we can actually have this game ongoing. So in the play iterations, we initiate a total reward to 0, so because we're going to keep track of it. And this takes in a number of iterations. And then we start a loop. We are going to get this number of iterations from user at the bottom of the code. Then we start an iterations and we actually print which game we're on, like game 1, game 2, such as you see here. And we receive the observation info from the environment that reset method. And then we reset the environment. We get the observation message and we print the observation message, which is this green messages right here. Then we print the hand values, such as the dealer's card and the player's card. And then we enter another loop to actually play a single game. We get an action with the action method, which comes from the GPT 3.5-turbo in this case. You can also use GPT-4. Here the action name is hit. If action is 1, we can actually change this to draw. Maybe it makes more sense. If action 1, otherwise it's stay. And then we print what the action is, such as like this. Right here, like this one. This time the action was a hit. Then we receive the observation, reward, termination, truncation info from the environment step method. This comes from the reinforcement learning OpenAI Gym environment. Then we add the total reward, whether the reward is positive or negative. You want to keep track of it. Then we get the observation message. We again print the observation message. And then we get the hand values. And we print them. This method does that automatically. And then we see if the game had ended. And we print break when the game ends, and we print the winner, and then we say game over, and then we print the return, and then we break, and we check if we reach the number of iterations that is necessary. Then we ask the user whether they want to continue by pressing enter, or any other key will quit. The reason is because, let's say if we're going to play 5 games, if all of it were to play, it would be difficult to see them on the terminal. I'm just giving it a chance for us to observe the game and then move on to the next one. That's why I have this. Then we have the observe method, which actually takes in the observation, reward, all the reinforcement learning related stuff, plus gets the dealer's card and player's card, and then actually creates an observation message and appends that to the messages, so we can send it to the GPT API call and returns that message. And this is the function to act. I'm sorry, this is the underscore act, and this is the actual action that came with. I'm not really sure this came with the class itself, what the difference between those is. You might want to take a look into it, but it has something to do with tenacity. And after that, our class is done. Remember, this was our Gymnasium agent class. The entire time we were talking about the methods that came along with it and the ones that I have added. And then we define our environment to be a gym environment, blackjack version 1. We print the environment. We don't actually have to. And we define an agent as the Gymnasium agent from the class. We say chat OpenAI, model GPT-3.5-turbo, temperature 02, environment is the environment. And then we ask the user how many number of iterations to be played. Then we just play those iterations, and after that we close the environment. So let's run this again. Let's run this again and see the code in action. Before we do that, I just want to mention the Ecohive AI Academy. Again, you can search all my videos here along with the link to code downloads and the information for each video. It's ecohive.live. Link will be in the description. When we run this, we need to enter how many games we want to play. Let's just say 3. Then we start the first game. This time they break even. They both end up having the value 18, so nobody wins. Let's move on to the next one. This time the dealer wins because the player busted. Now our return is -1. Let's play one more. Again, this time dealer wins and return is -1. I'm not sure why this happens sometimes. It might be a problem with the original class. Because you see, I ran this again and twice dealer wins. And return is -2. Not really sure why the return sometimes doesn't add up. Here in this case, it did. Many times it does, but there we go, yeah. Player wins and we are at +1. Dealer wins and we are back to 0. Let me try one more. Player wins and we get a -1 reward. That, I'm not sure. This is something that the observation returns. So I'm not sure about that. Maybe there's a mistake there somewhere. But anyway, you can actually, interestingly, turn this and say that your goal is to maximize your returns, right? But actually, I can say here, you will respond with an action and will always try to lose. And now if we actually run this, and let's play, let's say 5 games. Let's play 5 games. And you see, every time the player actually is going to bust, even it's going to draw, even when it's not the correct action. See, dealer wins again because player busts. Again, player busts. We are at -3. Player busts, -4. And player wins, actually this time. So it's a prompting, but the 4 times it actually busted itself by drawing, even when it wasn't necessary. So you can actually modify this prompt. I guess this is pretty interesting. You can try to apply it to other gym environments. Play around with it. I'll make this available to my Patreon supporters. And thank you for watching. And please join us at Ecohive's Discord if you like to talk about these things. And see you in the next video. Take care.